All right, so this is our standard form, ax squared plus bx plus c. The first thing that we want to notice with this before we go through how to find the vertex is what a couple of these variables will tell us. So our number in the front, just like before, will tell us if our parabola is upward or downward. Okay, so if you look at this a value, if this a value is positive, our parabola is going to look like this. It's going to be an upward parabola. If our a value is negative, it's going to be a downward parabola. So just like before, if the very beginning was positive, it's going to be upward. If it's negative, it's going to be downward. Okay. Another thing on this for us to notice is that if you plug in 0 for your x's, the only thing that's going to be left is the c. So that's like our y-intercept. For our y-intercept, our x's are always 0, and the only thing on the x-axis, or if it's on the y-axis, the x's will be 0. You plug in 0 for x's, you're left with your c. So for you to note, the y-intercept is always this last number, this constant. Okay. So when we're in standard form, that's how you find your y-intercept. We can tell if it's upward or downward based on the a value, and that lets us know if there's a max or a min. Remember, if it's upward, that's a minimum, right? This value is a minimum. If it's downward, this value is a maximum. So some of y'all were having trouble telling which was which. That's how we know if the front is positive or if it's negative. Okay. All right, now we're going to go through how to figure out what the vertex is. We'll do vertex, axis of symmetry, max and min, and domain and range. So we have a formula to find our vertex, to find the x-coordinate of the vertex, and it is this. X equals negative b over 2 times a. So you're going to use the b and the a from your problem. The b is the one next to the x, and the a is the one that is in the front by itself, or with the x squared. Okay. So once we know what the x value is, for us to figure out what our y value is, we have to plug the x into our original problem. So the x of the vertex, we use this formula. And to find the y, you're going to plug in whatever you get into your equation. Okay, so we do the formula for the x, and then we plug that in to get the y value. That's how we find our vertex. And now we do everything like we did before. Once we know what our vertex is, our vertex tells us how it shifts and where it is on the graph. So your maximum or minimum, just like before, that's the y value of the vertex. You have to know this y value in order to know your maximum or minimum value. The axis of symmetry is x equals whatever the x of your vertex was. For your domain, it's the same as before. What was our domain on every single quadratic problem?
All real numbers.
All reals, right? So domain is all real numbers. And then our range is either greater than or less than, depending on if our parabola is up or down, okay? So if it's down, it's going to be y is less than or equal to the y value of our vertex. If our parabola is up, our range is y is greater than or equal to this number. So the y value of your vertex. So we're going to find all of the same stuff that we did before we'll do a couple problems just so you can see how we use this equation, and then everything else kind of falls into place. Okay. All right, so the first one we're going to do is y equals x squared minus 6x plus 6. This isn't in vertex form. We can't just say it shifts up and down this way because it doesn't have the parentheses or anything. This is in standard form, so we're going to have to, we'll first look at the beginning and the end to see what that tells us. And then we'll find our vertex using our formula. Okay. So first off, is this parabola upward or downward? It's up because the x squared is positive. So we know for sure, just looking at it, it's an upward parabola. And our y-intercept is our last number here. So what is our y-intercept? 6. So that means we're going to cross the y-axis at 6. It doesn't have 6 tick marks on here, but if it did, we would go ahead and draw that on there. And now we're going to go through and figure out what our vertex is. So I'm going to say x equals negative b over 2a. X equals negative b over 2a. The b value is negative 6, right? Because b is in front of the x. What's a negative 6 make? A negative makes a positive. Positive 6 over, and what is our a value? What's in front of this x squared? Hold that finger up with your, number up with your finger. What's in front of the x squared? A 1, right? So we get 2 times 1 down here. Okay. So 6 over 2 times 1, 6 divided by 2, and that's going to equal 3. So 6 divided by 2 is 3. So the x-coordinate of our vertex is 3. Okay. So for us to figure out our... Daviana, you have a question?
Yeah. Do we gotta make our graph like that all over to the left side like that?
No, you can do a normal graph. This one is just set up so that it graphs it in the middle of the thing.
Okay.
Yeah, it just had already like set where they needed to be, but you can just do a normal graph. So once you know the x-coordinate to find the y-coordinate, you're going to plug it into the equation. So we're going to plug 3 into every single x value. And this is where I like to just use my calculator so I'm not making little mistakes. Does everybody see I put the 3 into every x? So y equals 3 squared minus 6 times 3 plus 6. If you type that into your calculator, you would get, or you did it in your head, you would get negative 3. So our vertex is the ordered pair 3, negative 3. Was this going to be a maximum or a minimum value? Remember, our parabola is upward. So is this a max or min?
Min.
It's a minimum. And the minimum value is always the y value of your vertex. So the minimum is negative 3. Axis of symmetry is the x value of your vertex. So x equals, so hold that up with your fingers. What's the x value of a vertex? 3, good. Okay, then we'll do domain and range, and we'll sketch it. Domain is all reals. And range This is where we use the y value of our vertex. It's going to be, is it going to be greater than or is it going to be less than? Remember our parabola, it's going up, so is it going to be greater than? It's going to be greater than, right? So y is greater than or equal to 3, negative 3, sorry. So let's go ahead and graph 3, negative 3. Our number in the front was a 1, so we just do our normal pattern. Over 1, up 1, over 2, up 4. And we'll make sure all of our stuff is right. Our vertex is 3, negative 3. Good. It's a minimum value, and the lowest it goes is negative 3. Got that on there. The axis of symmetry that cuts through the middle is at positive 3. Good. Our domain is all reals all the time. And our range starts at negative 3 and goes up. And if the graph was drawn a little bit bigger, we would see that we would cross at 6 on the y-axis. You'll see how that would go up to 6 that way. If the number in the front is not 1, if it's like a 2 or a 3, you have to remember about your multiplier. So you go over 1 and up whatever that number is. That's what you'd multiply your y values by. Okay. All right. Let's try the next one. See how it goes. So for number 2, is this going to be upward or downward on number 2? It's negative x squared plus 4x minus 1. It is downward, right? Yes, Robert, you raised a hand. Did you mean to?
So
know what that did?
I'm confused where the A came from.
The a value, it's the number in front of the x squared. So there's an understood 1 there in front of the x squared.
Okay.
Because we labeled them at the beginning. This was the A, and then the B, and then the C. All right, so on number 2, we said there's a negative in the front, so it's going to be downward. This is a downward parabola. And our last number is negative 1, so that is going to be our y-intercept. So y-intercept is negative 1. So I'm going to go ahead and graph that on there just so I know it's going to cross it there. That's not my vertex. That's just where it touches the y-axis. And it's upside down, so it's probably going to look like this in some capacity. Okay. So for us to find our vertex, we have to start using our formula. X equals negative b over 2a. I always write the formula out, even though I know it, just to make sure I remember what I'm doing. What is our b value? B value, show me with your hands. Raise those fingers up. A, B, C. The B value is 4. B value is 4. So negative 4 over 2 times, and our A, the number in the front of the x squared, negative 1. That's negative 4 over negative 2, which makes a positive 2. So our x value of a vertex is going to be positive 2. Okay. Then to find our y value, what do we need to do with that 2?
Plug it in the equation.
Yeah, plug it into the equation. So to find our y value, we say negative 2 squared plus 4 times 2 minus 1. And that's going to give us 3, I think. But you could type it in the calculator if you want to. So our vertex is 2, 3. I'm going to go ahead and put it on the graph. That's at 2, 3. I'm going to sketch it while we're at it. It's upside down, right? We can fill the rest in. Jeremiah, is the vertex a maximum or a minimum?
It's a maximum.
Yeah, because it's the top, so it's a maximum. And the highest number we get to is 3. Our axis of symmetry, it goes straight down the middle at x equals 2. Okay. And the domain, all reals. And the range, we know we have 3 in there, and we have a y value, but is this one going to be greater than 3 or less than 3? Alex, what do you think? Greater than 3 or less than 3? Right, so y is less than or equal to 3. Okay, we'll do one more. We're going to do one that has a number in the front. And then I have to show you something that I forgot to show you last time about y-intercepts with the other kind of problems that we did. But this is really all that you're going to be asked to do today is to sketch the graphs, tell what the vertex is, so you have to know the formula and be able to plug it in, and then be able to know where you get the max or min from, which is the y value, where you get the axis of symmetry from, which is the x value. So you'll be doing the negative b over 2a in almost every single problem, because you have to have that to find the vertex. And once you know the vertex, that's how you get your other numbers. Okay. All right. Let's do this number 4. I don't want to do
Can
the
you
number
go back?
3.
I didn't get all
So,
that, Miss Roselle.
okay.
Okay, I got it.
All right, good. Okay, so we're going to do this y equals 2x squared minus 8x plus 12. So we always want to look at the beginning and see, is it going to be up or down? That's going to help us out. So this has got a positive 2, so our parabola is going upward, right? Okay. And our last number is 12, so our y-intercept is 12. That's our c value. Okay. And then it doesn't matter if we're at this point, if we're asked to find axis of symmetry or maximum or minimum or domain and range or just the vertex, we have to find the, we have to do x equals negative b over 2a if you're asked to do any of those things. So the only ones that you can do without doing negative b over 2a is the y-intercept and whether it's just a maximum or minimum, and if they don't ask what it actually is. That's a minimum when we get there. So now we'll do our x equals negative b over 2a. And our b value is negative 8. So negative 8 makes a positive 8. And what is our a value? Let's see, Paris, what is our a value from our problem? Paris, the a value, can you tell us? It's 2, right? So 2 times 2 is our a value. That's our number in front of the x squared. That's 8 divided by 4. And 8 divided by 4 is 2. So the x coordinate of our vertex is 2, and we're going to plug that in. So you can just type that exactly like it is in your calculator, especially if you have the school Chromebook with the calculator that pops up. Don't do anything different than just exactly how I wrote it like that. Minus 8 times 2 plus 12. If you can see, I don't know. Oh, my camera's not even working. I'll have to restart the thing after I'm done. I did not realize that. Sorry.
Wait, how do you get the 8 again?
This is going to
X.
Huh? How do you get the 8 again?
How do you get the 8 again? Yes,
okay, so it's going to be negative b. This is a, this is b, and this is c. So b is negative 8. So negative 8 makes a positive 8. And then the a is 2, so that goes in for a. So our vertex is the ordered pair 2, 4. Let's go ahead and graph it, might as well, and then we can do the rest. So our vertex is 2, 4. Our y-intercept was 12. And we have a multiplier of 2. So instead of over 1, up 1, it's over 1, up 2.
Miss Roselle.
And we're going to do, yes.
How do you know what the multiplier is?
It's the a value in the front.
Oh. Okay.
Just like the number in the front was on the vertex form. And that's the same number there. Okay. And then is this going to be a maximum or a minimum? Layla, you can go ahead and answer that since you're close to your mic, I bet.
A minimum?
A minimum, yep. And our minimum value is 4. That's the y value of your vertex. Axis of symmetry cuts it right in half at 2, x equals 2. And our domain and range. Domain is all reals. And your range, we're going to be more than 4 because everything is above it. Y is greater than or equal to 4. Okay. There are a couple of problems in your homework that are word problems, but embedded in the word problems are a quadratic. They're just asking for you to tell them the maximum or minimum value. So all you have to do, don't think, oh, I've got to do something hard and crazy because it's a word problem. To find a maximum or minimum, you just need the y value of your vertex. So if they give you a quadratic and it's in a word problem, just think, oh, well, the only thing we're doing in this section is doing negative b over 2a and plugging it in. So that's what you'll have to do on those problems. Anytime they say max or min, do the negative b over 2a, find the x, plug it in, and that is your maximum or minimum value depending. Okay.
How you get the range?
The range?
Yeah.
The range is always like where the y value starts. So this one starts at 4, right? See how that's the first place that the graph exists? And it's everything that's above 4. So my graph is drawn at when y is greater than or equal to 4. If your graph is going up like that, it'll be a greater than. If your graph is upside down, it'll be a less than.
Okay.
But you always use your y of your vertex. Okay. All right. So there is one thing that I forgot to do last class, and I want to make sure that y'all know how to do it. So this is from vertex form. And it's finding the y-intercept. When it's in standard form, it's easy. We just look at the number at the end, but the number at the end in vertex form is actually how much you shift up or down. That's the number from your vertex. So you can't just look at that for your y-intercept. So for us to do it in vertex form, we have to plug 0 in for all the x's. So we plug 0 in for the x. I think there might just be one x actually in the problem. And then you solve that. So we'll show you one real quick to figure out. So you'll know how to find it if it's in vertex form. And remember, this is your vertex form. So if it looks like that with the parentheses, you can't just say the number at the end is the y-intercept. It's not. That's your up and down shift. So to find your y-intercept, you've got to plug 0 into the x value. So if we had this problem, y equals x minus 2 squared plus 4, and we wanted to find the y-intercept, it is not positive 4. The positive 4 tells us how much we're shifting our graph over. So to find our y-intercept, we've got to plug 0 in for our x, and then we evaluate it. Okay, and you can just type that right into your calculator, no problem. This is going to be 4 plus 4, and that makes 8. Okay, the number on the end is not the y-intercept. That is our transformation. Remember, this graph is going to go right 2, up 4, has a vertex of 2, 4. It does not have a y-intercept of 4. Its y-intercept is 8. You just put 0 in there and type it in the calculator. Okay, I put a couple of those in your homework assignment just because I forgot to last time. So the important formula that we need to know that we'll be using almost every problem is negative b over 2a. Okay. I also put a few review questions from last time so that you'll just have a reminder of doing transformation graphs. So the first couple problems are just transformation graphs, and then it goes on to this stuff. But make sure that you are writing your work down for this. I need to have your work turned in because you'll have to do so much with the negative b over 2a. So please work out these problems on your paper and turn that paper in as well as your notes. Okay. You guys have a lot of time to work today. You should be able to finish a whole bunch of this. Make sure you are working diligently and asking questions when you need to.